Okay, good morning. Now, today I would like to discuss about the sequential circuits. As per the sequential circuits, first of all, I would like to discuss about the latch. Okay, so already you studied about the latches also in the DELD subject. Okay, so now coming to latches. Okay, you know different types of latches like SR latch, D latch, like that. So, but the basic one is SR latch. Okay, the basic one is known as the SR latch. Usually these latches are designed using universal gates, NOR gates or NAND gates. Okay, using NOR gates and NAND gates, the latches are usually preferred. Okay, that too here there is a back-to-back connection of gates you can observe in this case. So let us observe NOR based SR latch, NOR based SR latch. Okay, so this is the circuit diagram of NOR based SR latch. It has two inputs, one is R and another one is S. Two outputs Q and its complement, say Q bar. Okay, so both the inputs you can take as R means reset, S represents the set. And in latches, you know already what are the different states you can observe are no change state, set state, reset state, undefined one. Okay, so these are the different types of outputs you can observe in case of latches. Okay, so I think you all know about the operation of the SR latch. Okay, using NOR gates, especially in this case I have taken the example of NOR gates. So what is its functionality? If both inputs are 0 0, if both inputs are 0 0, that is R is 0, S is 0, you can identify no change state, no change, or previous state. Okay, that means previously, suppose if the state of the latch is reset, it always stay in the reset state, or if it is a set state, it stays only in the set state. Okay, so like that, for 0 0 input, the latch maintains, that is the RS latch maintains same state. Okay, same state. For 0 1, 0 means S is 0, R is 1. See here the truth table, S is 0, R is 1. So since R is 1, R means what I said, R refers to reset. Okay, reset. Okay, suppose if the latch in set state previously, it comes to reset mode, or if it is in reset, it maintains same state. Okay, so whatever it may be, at the output you can see reset mode. Reset mode means Q value is 0. Okay, or reset state Q value is 0. Next, S is 1, R equal to 0. Now the combination applied at the input is S is 1, R is 0. So for this one, what is the meaning? Since S is 1, set the latch. That means it is set the latch. So the expected output is logic 1. The expected output is logic 1 in set case. Suppose if the latch is previously in set mode, it maintains same state. Otherwise, if it is in reset mode, it comes to the set state. So whatever it may be, expected output Q value is 1. Okay, and in 1 1 case, so see in 1 1, R equal to 1, S equal to 1 1 case. Okay, so the output you can't define whether it is set state or reset state. Okay, so that's why it is treated as a undefined state. Okay, in 1 1 case, both the outputs Q and Q bar settled in at one value. So that's why we can't say it is a set or reset state. Okay, so that's why it is considered as an undefined state. Okay, so we can't define whether the output is in set state or reset state. That's why it is referred as the undefined state. Okay, so like that you can consider the RS latch truth table and functionality using NOR gates. Also we can okay, first of all let us see the VHDL program for this latch. Okay, so when you go for writing the VHDL program, so first of all what you have to write, library IEEE. Okay, library IEEE. This is the standard library you have to open. Okay, standard library you have to open initially. From that library, one package you have to use, that is use IEEE.standardlogic1164.all. Okay, so in order to use different declarations available in the standard logic package, that package you need to put in the open mode. Okay, so after that, entity declaration. You all know already the entity declaration, how will be declared means using the word entity. See here, entity, name of the entity RS Latch is port of how many inputs and how many inputs are mentioned here. So you know RS Latch has two inputs, S, R, and two outputs, Q bar, right? So their names here represented as S colon in standard logic, R colon in standard logic, Q is the same Q not only acts as a output, it also acts as a input. Okay, so therefore the mode for Q is in-out. Okay, in-out means acts as both input and also output. So in-out standard logic. Similarly, Q bar is here the name given as Qn, that is negation of Q. It is also acts as a output and at the same time acts as a input for the other gate. So in-out standard logic and end SR latch. Okay, is it clear? So since the feedback connection is there in RS latch, both the outputs Q and Qn are at the in-out mode. They act as both input and also output. So that's why the mode is in-out. Then coming to architecture. So architecture, how to write the architecture is, start with the word architecture followed by architecture name. Data flow here I have written because I am going to write the program in the data flow style of RS latch. What is RS latch? Name of the entity. Okay, is, because you know the syntax is architecture name of entity name is, then begin, architecture begin. So after begin, since the model we are going to write is data flow model, we need to have the Boolean expressions for the both the outputs. Okay, what is the expression for Q? That is it is through NOR gate means just R NOR Qn, whereas Qn is S NOR Q. Two equations we have, that is RQn whole bar, SQ whole bar. Okay, so those expressions directly in the data flow model, the statements are known as concurrent signal assignment statements. Their appearance is similar to Boolean equation. Therefore Q less than equal R NOR Qn less than equal to S NOR Q, and data flow. Okay, so this is the VHDL program for the SR latch. Okay, then coming to another model of latch is using clock signal. How FR is SR latch can be explained. Okay, and what is the purpose of clock signal? So in order to get synchronous operation, generally a clock signal is used as an input. Okay, based on the if the available clock is required one, then only the latch shows its action, otherwise nothing. Okay, so this is the connection of RS latch including the clock signal. This is the latch connection. Okay, so the inputs are S, R and clock. Inputs are here, different inputs. SR already you know, SR are the inputs, set input and reset input, and another input is clock. Okay, so if clock is 0, that is if you take previous basic latch, both the inputs are 0 0, in that case what is the expected output? No change. Okay, so same thing here, previous state, Q previous. Okay, that is previous state. Suppose if clock is 1, the output of first level AND gate depends on the R value and S value. If they are 0 0, again For for the from when the clock is 1, it normally acts as a basic RS latch. Basic RS latch. For 0 0 no change. For 0 1 reset state 1. For 1 0 set state. For 1 1 undefined state. Okay, so when clock signal is 1, then only it shows the RS latch functionality. Otherwise it is in the previous mode. Okay, so this is the controlled latch using the clock signal, we can say. For this one, how to write the VHDL program means. Okay, so here also same thing, one more. First of all, you have to write the entity. First of all, write the entity declaration. In that entity declaration, include clock also. Include clock. In previous case there is no clock. Now you include C, clock signal. Then here I have shown directly the architecture body of this RS latch with the clock signal. So behavioral structure. Okay, this is the behavioral model for the same RS latch. Okay. Yes, see here. So entity, in the entity with the control input, declared S is one input, R is an input, C is the third input, Q, Qn are the outputs, Qn are the just outputs, out. Okay, initially, but they are initially assigned with Q is with 0 and Qn is with 1. That is the latch in the reset state. That means the latch in the reset state. Okay. Then architecture, behavior of SR latch control. Architecture name of entity name is begin. Then process of usually the inputs, the sensitivity list in the process are inputs S or C, then begin. Okay, that means when process statement is used, what is the model? Behavioral model. So begin. First of all, you need to check out the clock signal. If clock equal to 1, then if S equal to 0 and R equal to 1, S0 R1 means reset state, right? So Q is 0, Q bar is 1, or Q bar means negation of Q is here, Qn equal to 1. Else if this condition is failed, now it is going to check another combination of S and R values. If S is 1 and R is 0, then the expected outputs are Q is 1, Q bar is 0. Else if S is 1 and R equal to 1, both 1 means undefined state. Okay, in undefined state case, the expected outputs you can write as Q is hyphen, Qn also hyphen. So end if, end process, end behavioral. Okay, so two end ifs here. One is for clock, for the first if, which is used for the checking the clock signal, and another one is for checking the S and R inputs. Okay, so like that, in the behavioral model case, you can write the program. Okay, why here Qn not declared in the form of in out? Because directly we are assigning the values in the program flow. Okay, in program flow we are directly assigning the values. That's why here the values are like this. We are not assigning Q to something, Qn is to something. That's why just here we are using both Q and Qn as outputs only, not the inputs. Okay, we are not using them as input. We are using it is programming style. Based on the programming style, the Q and Qn are declared only in the form of out. Okay, so this is the behavioral model program for the controlled SR latch. So in previously what I have shown, this is the behavioral level program or behavioral model for the same SR latch, but there is no control signal. See here, there is no control signal. Here. Control clock signal we are not checking. Only S and R values are checking. Okay. So previous model is data flow model. This is the data flow model. Directly signal assignment statement are used. But this is the behavioral model. Using the process statement, you can write the program. but without the clock signal, and this program represents the with clock signal, okay. So in the same way for other flip-flops like other latches like D latch mainly, another important latch is the D latch, okay. After that we just move to the flip-flops, okay. So you develop the program for D latch, okay. So in the next class I like to discuss about the flip-flop, right. Thank you.